on this 2010 through 2017 Honda Accord with the 2.4 gas engine. P1298 points to an ELD circuit high voltage fault. In plain terms, the PCM may be seeing an electric load detector signal that does not make sense for the actual electrical load. The vehicle may have a check engine light, and charging or load control behavior can be affected. The broad fault areas are the ELD power feed, the ELD signal circuit, the ground side, connector condition at the ELD or PCM, the ELD itself, and in some cases PCM software or PCM substitution checks. Before testing, save the captured data and any onboard snapshot so you know what conditions were present when the fault set. Start by turning the ignition on or selecting on mode and look at the ELD value with the HDS. The decision point here is whether ELD, electric load value, is less than 0. 2A. If the failure is duplicated, continue into the circuit checks. If it is not duplicated, treat it as an intermittent at this time and inspect for poor connections or loose terminals at the ELD and the PCM before going any deeper. Next, check the IG1 ACG feed to the ELD. Turn the ignition OFF, disconnect the ELD 3P connector, then turn the ignition back on. Measure voltage between ELD 3P connector terminal No. 3, the pink wire, and body ground. You are looking for battery voltage on that feed. If battery voltage is there, the IG1 ACG wire is okay and you move on to the ELD signal wire. If battery voltage is not there, check the No. P1398 fuse in the underdash fuse and relay box. If that fuse is okay, repair the open in the IG1 ACG wire between the No. B13 fuse and the ELD, then verify the repair. For the ELD signal wire check, turn the ignition OFF, jump the SCS line with the HDS, and disconnect PCM connector A, the 51-pin connector. With the ELD connector still disconnected, check continuity between ELD 3P connector terminal No. 1, the white wire, and PCM connector a terminal No. 46, also the white wire. If you have continuity, the ELD wire checks OK and you move to the ground circuit. If you do not have continuity, repair the open in the ELD wire between PCM terminal A46 and the ELD. Then verify the repair. Now check the ground side. With the ignition OFF, the ELD 3P connector disconnected, and PCM connector disconnected, check continuity between ELD 3P connector terminal No. 2, the black wire, and body ground. If continuity is present, the ground wire is okay, and the next step is an ELD substitution check. If continuity is missing, repair the open in the ground wire between the ELD and G301. Then verify the repair. If the feed, signal, and ground circuits all pass, substitute a known good ELD. Reconnect all connectors, turn the ignition on, reset the PCM with the HDS, and do the PCM idle learn procedure. Then check for pending or confirmed P1298 with the HDS. If P1298 is still indicated with the known good ELD, update the PCM if it does not have the latest software, or substitute a known good PCM, then verify the repair. If P1298 is not indicated with the known good ELD, replace the original ELD, then verify the repair. Keep the repair verification separate from the circuit testing. Turn the ignition OFF, reconnect all connectors, exit SCS mode with the HDS, turn the ignition on, reset the PCM with the HDS, and do the PCM idle learn procedure. Then check for pending or confirmed DTCs with the HDS. If P1298 is still indicated, go back to connector quality at the ELD and PCM. If the PCM was updated, substitute a known good PCM and recheck. If the PCM was already substituted, return to the beginning of this diagnostic path instead of guessing. If P1298 is not indicated, troubleshooting for this code is complete. If the PCM was substituted and the code stays gone, replace the original PCM. If other codes are present, diagnose those separately. The clean path on P1298 is to prove the fault is active, prove the ELD feed, signal, and ground circuits, then use substitution and verification only after the wiring checks pass. For more diagnostic training, visit stepdiagnostics.com.